Hi everyone, today we're going to start in on chapter 11, which is quite intuitive, so your brain is not going to have to work quite as hard for today's class, which should be great news. The title of the chapter is Moral Hazard. This may be familiar to you if you're studying risk management, and if you're not, then I'll just get you up to speed on what moral hazard is and why we care about it in health economics. So the basic idea that we're going to kind of try to wrap our mind around is what would happen if having a person get insurance causes the likelihood of that person to get sick to change. So conceptually, you can kind of think of two situations. So situation number one is there's a person without insurance. That person has some probability of getting sick. Maybe it's P equals 0.2. And then the alternative, kind of counterfactual for this person, is what the person's probability of getting sick would be if they had insurance. So maybe, as I'm going to argue, it's plausible that if you give a person insurance, that might cause the probability of them getting sick, their P, to increase. So maybe the person who is handed insurance would see an increase in their P from 0.2 to 0.3, for example. Okay, so I'm going to explain why this might be a concern for us. To begin with, I'm just going to start with the definition of moral hazard. The definition of moral hazard is when protection against the cost of a bad outcome reduces a person's incentive to avoid a bad outcome. Okay, what is a bad outcome? So a bad outcome here, in the context of health insurance, would be things like getting sick or breaking your bone or having some kind of other injury. So we're going to think about bad physical outcomes. And so here, for moral hazard, we're thinking about what would happen when a person is protected from the cost of getting sick, and moral hazard says that may reduce a person's incentive to avoid getting sick. Okay, to begin with, there are two types of moral hazard. Type 1 is ex ante moral hazard. Okay, ex ante moral hazard is a behavior change that happens before an insured event. For example, medical bills from broken bones, and that behavior change makes that event more likely. Okay, let me give you a concrete example. Suppose a person is thinking about going skydiving. Well, whether a person decides to go skydiving is probably going to depend on whether they have health insurance, because there's a risk of jumping on a cliff, landing in shallow water, and breaking your bone. And in the event you break your bone, which is a bad event, then you're going to have to go to the hospital, and there's going to be some medical costs associated with that broken bone. Okay, the big kind of important thing that distinguishes ex ante moral hazard from the other type of moral hazard is the timing of a person's behavior change relative to the bad event. So ex ante moral hazard is characterized by a person deciding to change their behavior or go cliff diving as a result of insurance or as a result of being insured before the broken bone occurs. So the idea is a person has no insurance, they're probably not cliff diving a lot, you hand them insurance, the first thing that happens is they start cliff diving more. So that's the behavior change, like cliff diving increases. And then after the cliff diving increases, what happens? You start getting more broken bones. So conceptually, the insurance kind of led to the additional broken bones, because when you got the insurance, you cliff dived more, the behavior change, and when you cliff dive more, you break more bones. Okay, the other type of moral hazard is ex post moral hazard. Ex post moral hazard entails behavior changes that happen after an insured event happens. For example, medical bills from broken bones. And that behavior change makes recovering from that event more expensive. Okay, again, the thing that distinguishes ex ante and ex post moral hazard is the timing of the behavior change relative to the bad event. So ex post moral hazard occurs when after the bad event or after the broken bone, a person changes their behavior, and that behavioral change makes recovery more expensive. So as an example, suppose a person doesn't have insurance and they break their bone. So the first thing that happens is bone is broken, And now when they're at the hospital, the doctor comes in and they say, what kind of cast would you like on your leg? Well, the bad event has already happened. If you don't have insurance, you're probably going to say, I just want a plain white basic cast with no frills because I'm going to have to pay for the cast. But if you take that same person and you kind of make them insured, well, then when they're sitting in the hospital with a broken bone, so the bad event has already happened, then if they have insurance and the doctor comes in and says, what kind of cast would you like? The person's much more likely to say, oh, I want the fancy cast that has the pretty colors and kind of all the bells and whistles, because if they're insured, they're not going to have to pay for it. And so what has happened? Well, recovery is more expensive now. Like, getting the fancy cast is more costly, and getting the fancy cast happens more often amongst the insured people relative to the uninsured people. Okay, so again, just to make this like abundantly clear, what distinguishes ex ante and ex post moral hazard is when you change your behavior relative to the timing of the bad event. So for ex ante moral hazard, you hand a person insurance. What happens? They start cliff diving more. So that's the behavioral change. And then after that, you get more bad events. You get more broken bones. Ex post moral hazard is a person has broken their bone. That's the first thing that happens. Then after the bad event, if you give a person insurance, then they change their behavior and start requesting kind of more expensive treatment that may not be more effective, but it's more expensive. And so recovery is just more expensive. Okay, for either type of moral hazard, there's a pattern that kind of follows when it comes to insurance causing the moral hazard. So the pattern is step number one, a person gets insurance. The insurance shields them from either some or all of the cost or the price of a bad event, which in the example I've been giving you is the cost of paying for hospital bills that stem from broken bone visits. The second thing that happens is that in response to the price distortion, a person changes their behavior. So they can change their behavior in one of two ways. So again, way number one is they may change their behavior in a way that increases the likelihood of the bad event. That would be ex ante moral hazard. Way number two is they could change their behavior in a way that increases the cost of recovering from the bad event. That would be an example of ex post moral hazard. Okay, the third thing that happens is the person's behavior change, which is now kind of characterized by riskier behavior, less responsible behavior, that's going to cause a social loss or extra money to be spent that otherwise would not have materialized if the person had not had insurance. So the idea is if you start out in a world where nobody has insurance, well, there's probably not going to be a lot of broken bones in that world from people jumping off of cliffs, because if no one has insurance, people are going to be kind of leery to jump off of cliffs. So we have this social loss when we switch over to a world where you give everybody insurance, because now people are a little bit more reckless. They're jumping off more cliffs. And suddenly in this insured world, we have more broken bones. Similarly, if you have one world where nobody has insurance, well, then if somebody breaks their bone in that world, they're going to choose kind of the basic treatment that will be sufficient, and that's kind of the most cost efficient. Whereas if you have a world where everybody has insurance, then anytime somebody breaks a bone in that world, they're getting kind of these crazy expensive casts that look pretty, and that results in a social loss because we're kind of throwing more dollars at the same problem, having a cast around a leg. We're just spending money on something that's actually not doing us any good in terms of recovery. Okay, so how do we measure the extent of the social loss, or the amount of extra money we're just kind of burning as a result of people changing their behavior, which comes as a result of them having insurance? Okay, so to measure social loss, let's think about what the price of cliff diving would be without insurance. So the price for cliff diving, if a person is uninsured, so P subscript U, would be equal to the sum of all the individual things they'd have to pay for when they go cliff diving. So the price of cliff diving when you're uninsured, first of all, is going to include the price of a plane ticket so you can get to a cliff. It's also going to include the price of a hotel so that you can stay at that location. And then it's also going to include the expected price of medical bills that you'll have to pay out of pocket in the event you break your bone from jumping off a cliff. Okay, now let's compare to that what the price of cliff diving would be if a person has insurance. So this is P subscript I. With insurance, the price of cliff diving would include the price of a plane ticket, because if you're going to cliff dive, you still got to get to the location. It's also going to include the price of a hotel to stay at that location while you're jumping off the cliffs. But now it's no longer going to include the expected cost of medical bills, because if you're insured, the medical bills are no longer on your plate. The insurance company is paying for your hospital bills if you have insurance. So think about this. The same event, cliff diving, has experienced a price change or a price distortion when a person goes from the state of the world of being uninsured to being insured. And specifically, when you go from being uninsured to insured, the price of cliff diving falls because PI is smaller than PU. Okay, according to the law of demand, we would expect people to cliff dive more when the price falls from PU to PI. And the reason for that is because the demand curve slopes down. So if you have a demand curve and you start with a high price, the corresponding quantity demand is going to be somewhat low. If from that position you lower the price, well, what happens? People just demand a higher number of units, because the law of demand says as the price falls, quantity demanded rises. Okay, what we can do with this demand curve that plots on it the price of a bad event when a person's uninsured and the price of a bad event when a person is insured is we can calculate the actual magnitude of the social loss by looking at a particular area on the graph. So to do this, what you need to do is you first need to figure out what the price of the bad event would be when you're uninsured, and then based on that location of the price, determine the corresponding quantity of cliff diving in the event a person is uninsured. Similarly, you look at the price of the bad event, cliff diving, if a person is insured, it's lower, and then find the corresponding quantity demanded of cliff diving if a person is insured. And then what we're going to do is we're going to kind of enclose those coordinates and around them draw a triangle that is above the demand curve. Okay, that triangle is going to have an area to it. The area of a triangle is 1/2 base times height. The base is going to be QI minus QU. The height is going to be PU minus PI. So with these two coordinates and a linear demand curve, you can calculate the area of the triangle. That area is going to correspond to a dollar amount, which is the extent of the social loss. Okay, so for example, suppose you find the area of a triangle is $1 million, for example. Okay, so what that would tell you is that if the area of the triangle in the cliff diving world was $1 million, then the amount of social loss that would occur if you gave everybody insurance for broken bones that happen as a result of cliff diving would be $1 million. So conceptually, what is this social loss, or these $1 million? Okay, it is the extra money, labor, time, and whatnot that are spent caring for people who cliff dive more than the optimal amount, QU. So the idea is if people kind of fully internalize the full cost of the bad event occurring, then they would be very responsible and they cliff dive the optimal amount. That amount would coincide with the amount they would cliff dive if they were uninsured, because if you're uninsured, you're actually internalizing the full cost. So we're going to say QU is the optimal amount of cliff diving. That would be the optimal amount of cliff diving. If you have everybody insured, then the amount of cliff diving that's actually going to happen is QI. Okay, for reasons we've talked about, if you have more cliff diving, you're going to have more broken bones, you're going to have more people sitting in the hospital, you're going to have more casts that have to be made. And so the idea is those $1 million in social losses, that would be the amount of extra money that has to be burnt caring for these extra bones and also kind of giving people fancier casts because they have insurance. So it's the difference between the total spending on broken bones that would happen in a world where nobody's insured relative to the amount of money we would spend to care for broken bones in the world where everybody is uninsured. So in this case, it's like you have to spend an extra $1 million to fix this problem in this hypothetical world where everybody has insurance. Okay, one thing that's important to keep in mind is that the extent of social loss for a bad event depends on several things. The first thing it depends on is the elasticity of demand for that good. So what I have right now is a head-to-head comparison of two goods that have different price elasticities of demand. In the first graph, you can think about a good that has a very inelastic demand. So this would be a good where people are relatively insensitive to the price. Okay, another good might have an incredibly elastic demand. Okay, what I've done here is I've kind of normalized the price change so that we can compare how many units of the inelastic and elastic good a person would buy if there was a fixed price amongst people who are uninsured. And then the PI stands for the fixed price for each of those two goods that would exist if people had insurance. So again, note when you have insurance, this lowers the price of whatever thing you're looking at. Okay, the idea here is that for these two goods, if you lower the price by the exact same amount, you get different responses in terms of the increase in the quantity demanded. So in the inelastic world, you lower the price by a fixed amount, you get a small increase in the quantity. In the elastic world, you lower the price by a given amount, you get a huge increase in the quantity. Okay, so now we have two triangles. The sizes of these two, or the areas of these two triangles, tell us the extent of social loss that exists in either market. The social loss is much, much bigger in the elastic, for the good that has the elastic demand, because while the height of both of those triangles is the same, the base of the triangle is so much bigger in the market where the good has an elastic demand. So you can think about how this would kind of affect things that we care about. So the idea is, let's think about smoking, for example. People have a pretty inelastic demand for smoking. And so if you gave everybody insurance that covers the cost of lung cancer treatment, so you get lung cancer, you're more likely to get lung cancer if you smoke. Well, even if you made lung cancer treatment super, super cheap, well, people aren't really going to cut back their smoking by a whole lot, or increase their smoking by a lot, because they think, oh, well, if I get lung cancer, then it's going to not be a huge expense to me. They're not really going to smoke more as a result of cheap lung cancer treatment. And so in that type of market, there's really not going to be a huge social loss from changing the price of lung cancer treatment. The second thing that the magnitude of the social loss depends on is whether the insurance that a consumer has is full or partial. So let's consider now a particular market. So now the graph on the left and the right are going to represent the exact same good on the market. But in the first graph, let's think about what would happen if a person was fully insured, and then in the second graph, let's think about what would happen if the person was partially insured. Well, if a person is fully insured, then that means that if they get sick, then the insurance company will pay all of their medical bills. So when you go from being uninsured to being fully insured, there's going to be a pretty big reduction in the price of medical care. On the other hand, if a person is partially insured, then that means that in the event you get sick, the insurance company will pay a part of your medical bill, but they're not going to pick up the tab for the entire thing. So when a person goes from being uninsured to being partially insured, it's going to lower the price of their medical treatment by some, but not as much as when they're fully insured. Okay, what this means now is that this is going to result in two different triangles that have two different shapes. So in the fully insured world, full insurance causes the price to really fall, and so the height of the triangle is going to be relatively bigger. And if you have a bigger decrease in the price, you're going to have a larger increase in the quantity demanded. And so there's going to be quite a bit of social loss when you give someone full insurance. Whereas if you give somebody partial insurance, the demand curve is the same as before, but because we're not looking at as big of a height, we're going to get a smaller base as well, and so the social loss is going to be smaller. This should be very intuitive. The idea is that the more you take the sting out of a bad event, the more reckless people start behaving. So if you give somebody like full insurance that just covers whatever bad event might happen to them, then the person has no incentive whatsoever to live a careful life that kind of tries to tiptoe past the bad event. As a result, we get lots and lots of social loss because they're behaving in a quite irresponsible manner. On the other hand, if you give somebody insurance, but the insurance still leaves a little bit of a sting for the customer in the event that they experience a bad event. So in other words, it's kind of like, well, if you break your bone, we'll pay half the medical bill. Well, in that case, the person actually has to pause a little bit and think, okay, well, if I jump off this cliff and break my leg, I'm not going to have to pay the full medical bill, but I'm still going to have to pay the hospital a little bit. And that actually causes them to rein in their behavior a little bit and behave in a way that's somewhat more responsible than if they are fully insured. And so partial insurance results in less social loss because people are a little bit more conscientious about their behavior, given that some of the sting of the bad event is still felt by them. Okay, related to that, the extent of the social loss is also going to depend on whether there's cost sharing. Okay, what is cost sharing? Cost sharing is kind of similar to partial insurance. The idea is that cost sharing is when, after a medical bill is accrued, the consumer pays a part of it and the insurance company pays a part of it. So an example of a cost sharing mechanism is copayments. So basically you've got a similar graph that we can use to predict what would happen in terms of cost sharing relative to the old graph that we were looking at when we were thinking about full versus partial insurance. So on the left we have what would happen if a person had no copayment. So if you have no copayment, then the price for something is going to fall by a lot if you have no copay to pay. In the event that you're still stuck with a copay, then in the event the bad event happens, your price is going to fall by some relative to the amount you had to pay when you're uninsured, but it's not going to fall by as much as it would if you had no copay you had to pay. So for the same reasons we've talked about, the area of the triangle is going to be bigger, or the social loss is going to be larger when there is no copayments relative to if you impose some copayments in the market. And the intuition is identical as before. The idea is if you make a person pay a copay, then in the event the bad event is realized, they're going to feel a little bit of sting because they've got to pay the copay. So that little bit of sting is going to kind of dissuade them from being entirely reckless, and so the social loss won't be quite as extreme. Okay, there's going to be a couple takeaways I'm going to give you, and then we'll wrap up the chapter with that. So the takeaway is there's reason to be concerned that, number one, insurance will cause people to behave riskier. So this is consistent with ex ante moral hazard. The idea is if you give someone insurance, then first thing that happens is they start going out jumping off of more cliffs, they start riding motorcycles with no helmets, they change their behavior in a way that makes the bad event more likely to happen down the road. So they're behaving in a riskier way. Okay, there's also reason to be concerned that insurance will cause people to wastefully consume more medical care than they need if they get sick or if the bad event happens, and we call this ex post moral hazard. So the idea for this is if you give somebody insurance, well then after the bad event happens, when you've got the insurance card, you're going to pick the name brand medicine instead of the generic. You're going to pick the fancy casts instead of the plain white ones. And so the expense or the dollars that are spent to care for your problem are going to be larger when you have that insurance card. And so your decision points are going to change after the broken bones when they're asking you what kind of cast you want, or after you get sick and they're asking what brand of medicine you want. Okay, importantly, both types of moral hazard result in social loss because the economy is spending more resources than are necessary in either case. So either they're just fixing more broken bones, so you've got to have more doctors to care for these patients, you've got to use more x-rays, and you're just spending more resources because there's more broken bones, or you're spending more resources because given the number of broken bones you have, you're kind of opting for the most expensive treatments, and that's kind of a wasteful thing. Okay, the encouraging thing is that social loss can be somewhat eliminated if we let people feel some of the sting of a bad event. So, conceptually, the idea is if you leave a little bit of money that a person has to pay in the event they get a medical bill for having an injury or illness, then that will kind of cause a person to be a little bit more careful in their decisions, and so social loss will be minimized. And then the final thing, which isn't in your class packet, but I'll just kind of note this as the final takeaway, is we're going to get more social loss in markets where the demand for that thing is more elastic. Okay, so that's it for this chapter. If any of this is confusing or if you have any questions, reach out in the next 10 minutes, and then we'll go for the exercise after that. for the exercise today, I'm going to have you think a little bit more deeply. So in the lesson, when I was showing you how to calculate the area of social loss, I just gave you a picture for the demand curve. And for this exercise, I'm going to give you an equation for the demand curve. So the question is, suppose the price of sunbathing, which includes the expected cost of future chemotherapy for skin cancer, is $100 when a person has no health insurance. However, when a person has full health insurance that covers the cost of chemotherapy for skin cancer, the price of sunbathing falls, and because medical bills are not their responsibility anymore, the price of sunbathing with full health insurance will be $10. When a person has health insurance that entails a copay for chemotherapy, the price of sunbathing is going to be in the middle of those two previous prices, and the price of sunbathing with a copay, with an insurance that has copay, is going to be $30. Okay, suppose the demand curve for sunbathing is of the form Q equals negative 1.5p plus 200. Okay, first thing, with this equation that I've given you, you can actually plot the demand curve. It's going to be linear. So that's option one. You can take this equation and actually draw out the demand curve. Option number two is I've given you different prices. So you can take those prices and just plug them into the equation, and a Q will spit out. Once a Q spits out, you'll have a price quantity coordinate. Each of the price quantity coordinates that you have will be a specific spot along the demand curve. So you can also do that. Okay, what you will need to definitely have, though, is 3 different price quantity coordinates. One that goes with the uninsured price and quantity of sunbathing, the full insurance price and quantity of sunbathing, and then the copay price and quantity of sunbathing. And then with that, I'm going to have you calculate social loss. One helpful hint is that social loss, again, is equivalent to the area of a triangle. The area of a triangle is equal to 1/2 base times height. So memory work if you don't know that. Okay, question number 1 is how much social loss would be generated if everyone had full insurance that covers the cost of chemotherapy for sunbathing? Helpful hint to calculate this, the 2 relevant prices that you're going to need to look at are the price when people are uninsured and then the price when they have full insurance. Question number 2 is how much social loss would be generated if everyone had insurance that entailed a copay for chemotherapy. Here, the 2 relevant prices are the price when someone's uninsured and then the price when they have insurance that entails a copay. And then the last question is not wearing sunscreen because you have health insurance an example of ex ante moral hazard or ex post moral hazard? One final helpful piece of information I'm going to give you is that you definitely need to know how to determine the difference between whether a situation is an example of ex post or ex ante, because more than likely questions like this will show up on the exam. So I might give you a particular scenario, and then I would say, is this scenario consistent with ex post or ex ante moral hazard? Okay, so if any of that isn't clear after you do the work and get the correct response back, reach out and I'll try to clarify things. And otherwise, that will be it for the day.